Hi all, welcome to Learn Easy channel. Today's topic is VSEPR theory, that is valence shell electron pair repulsion theory. This theory helps in predicting the shape of the molecules. First we will see the postulates of this theory. The shape of the molecule depends on number of valence shell electron pairs around the central atom. This valence shell electron pairs includes bond pair as well as the lone pair. For example, if you take the ammonia, in the structure of ammonia there are 3 bond pairs and 2 lone pair of electrons. There is nothing but this only we are referred to as lone pair, and this one is the bond pair. There can be 2 pairs of lone pairs also. There will be repulsion between these 2 bond pairs, and there will be repulsion between this bond pair and the lone pair. There will also be a repulsion between these 2 lone pairs also. So, the lone pair or bond pair gets arranged as far as possible in space to avoid the repulsion. Because there is lot of repulsion, to avoid the repulsion, the lone pair and bond pair will be arranged in possible space so that there will be minimum repulsion in between those pairs of electrons. This leads to a particular shape or geometry of the molecule. The lone pair and bond pair are arranged in space to avoid to avoid the repulsion. Because of that, there will be some change in the shape or geometry of the molecule. Okay, the next one is, this is a very important point. The lone pair repulsion will be greater than the lone pair and bond pair repulsion than the bond pair repulsion. This will be this is a very important point in terms of examination. Next, multiple bonds, for example double bond or triple bond, they are considered to be a single bond. For example, in carbon dioxide there are 2 double bonds. But when you write the bond pair, you will write only 2, because we should consider this double bond into a single bond. So there are 2 single, we have to consider it to be a single bond. So the bond pair here is 2 according to VSEPR theory. And the lone pair, we should consider the lone pair only for the central atom and not for the side atoms. Okay, so the lone pair is considered only for the central atom. If you have a lone pair for the central atom, that only you have to consider it here in the case of VSEPR theory. These are the 4 important postulates of VSEPR theory. Next we will see the shape of the molecule with no lone pair of electrons. In this case, shape is equal to geometry. First we will see for the type AB type of molecule. Example for this is HF, HCl and HBr. Here the lone pair is equal to 0 and bond pair is equal to 1. Since there is only one bond, so A is bonded with B, it forms a linear shape. Since it is a linear shape, the bond angle is 180 degrees. Okay, next we will see for next type of molecule, that is AB2 type. The example for AB2 type is BeCl2 CO2. Here the lone pair is equal to 0 and bond pair is equal to 2. Since there are 2 bonds, it forms a linear shape and the bond angle is 180 degrees. Next we will see for AB3 type of molecule. Example for AB3 type of molecule is BF3 and AlCl3. Here the lone pair is 0 and bond pair is 3. Since there are 3 bonds, it forms a trigonal planar shape. All the 3 bonds will be in a same plane. The bond angle between these 2 bonds is 120 degrees. Next we will see for AB4 type of molecule. The example for this is methane, CH4, CCl4 and SiCl4. Since there are 4 bonds, it forms a tetrahedral shape and the bond angle is 109.5 degrees. Next we will see for the next type of molecule, AB5. The example for AB5 type of molecule is PCl5. Here the lone pair is equal to 0 and there are 5 bond pairs. Since there are 5 bond pairs, it forms a trigonal bipyramidal shape. These three bonds will be in a same plane, and one AB bond will be in the front and the another AB bond will be at the back. Okay, so it forms a trigonal bipyramidal shape. There will be two bond angles in this case. The bond angle between the two bonds, the bond angle between these two bonds is 90 degree, and the bond angle between these two bonds is 120 degree. Okay, next we will see for AB6 type of molecule. Example for this is SF6. Lone pair in this case is 0 and bond pair is 6. Since there are 6 bond pairs, it is arranged in octahedral shape, and the angle between the two bonds is 90 degrees. It forms a right angle with each bond forms a right angle with the other bond. So the angle between the two bonds is 90 degrees. Next we will see the central atom which has lone pairs of electron. The first type is AB2E type. The example for such type of molecule is O3, it is ozone. In this case there will be one central atom and two side atoms, B and B here, and E is nothing but a lone pair. Okay. So here the lone pair is equal to 1. There are only one pair of lone pair. So lone pair equal to 1 and the bond pair is 2. So bond pair is 2. Totally 3 electron pairs are there. So it forms a trigonal planar shape. Actually the arrangement of electrons will be in trigonal planar shape. Because there will be a repulsion between the lone pair and the bond pair, the shape of the molecule bend downwards. Because of that, it forms a bent shape. Okay. The next type is AB3E. The example for such type of molecule is NH3, ammonia. Here the lone pair is equal to 1 and bond pair is equal to 3. 3 bond pairs and 1 lone pair. Totally 4 electron pairs are there. So initially it forms a tetrahedral shape. The geometry of the electrons are arranged in tetrahedral shape, but because of the repulsion between the lone pair and these bond pairs, it forms a trigonal pyramidal shape. Actually these three bonds will actually occupy some space to avoid the repulsion. Because of that, it forms a trigonal pyramidal shape. Next we will see AB2E2. Example for this is H2O. Here the lone pair is equal to 2 and bond pair is equal to 2. Totally 4 electron pairs. In this type of molecule we have two lone pairs and 2 bond pairs. Here also it forms a bent shape and the angle between the 2 bond pair is 104 degree. Next we will see for AB4E type. Here the lone pair equal to 1 and bond pair is equal to 4. So totally there are 5 electron pairs. Since there are 4 bond pairs and 1 lone pair, because of to avoid the repulsion, it forms a seesaw shape. Seesaw shape because of this lone pair. When the lone pairs repel between this B, this bond moves up. When this lone pair repels with this B, this bond will move up. So it forms a seesaw-like structure. So it is called seesaw. The shape of this is seesaw. Okay. Next, AB3E2 type of molecule. In this, the lone pair is equal to 2 and bond pair is equal to 3. There are 3 bond pairs and 2 lone pairs. Totally 5 electron pairs. And initially it forms a trigonal pyramidal shape, but to avoid the repulsion it forms a T-shaped structure. So the shape of this is T-shape. Next we will see the next pattern, that is AB5E type of molecule. The example for this is BRF5. Here the lone pair is equal to 1 and bond pair is equal to 5. So totally 6 electron pairs. It forms a octahedral shape. The geometry of this is octahedral shape. To avoid the repulsion between the lone pair and bond pair, it forms a square pyramidal shape. So these are the different shapes for lone pairs of electrons in the central atom.